Hi everyone, today we are going to be talking about the exterior angle theorem. So when we're talking about exterior angles of a triangle, we're talking about an angle that is formed by one of the sides of the triangle being extended past a vertice or vertex. So that's going to be this angle here specifically. So if we look at an example where we're trying to solve for this exterior angle within this triangle, what we know from the triangle sum theorem is that all three angles in a triangle must add up to 180 degrees. So I can first start this problem by solving for angle Z. I'm going to take 79, I'm going to add it to 62, I'm going to add that to angle Z, and I know that those three angles added up must equal 180 degrees. And now I go through and I solve this problem. So 79 plus 62 gets me 141 plus Z equals 180. I now subtract 141 from both sides, and we are going to get Z equals 39 degrees. Once we know that, then we have to combine that with the fact that these two angles, Z and my question mark angle, form a line. So we know that they are supplementary, which means they must add to 180 degrees. So I know that 39 plus my question mark angle must equal 180. Well, I subtract 39 from both sides, and so I get that this missing angle has to equal 141. Hey, we just saw that number. We just saw it over here. And so this is an important thing to notice, that this exterior angle, my question mark angle, is actually equal to my two other angles within my triangle added up together. So this is the exterior angle theorem, that the measure of an exterior angle of a triangle is equal to the sum of the two non-adjacent internal or interior angles. And so, to reiterate that with our picture, non-adjacent being the two angles that are not touching this exterior angle. So all we have to do is add up my non-adjacent angles, and that's going to give me the value of my exterior angle. So let's practice this. Looking at this problem, I'm solving for angle TYL. So this guy right here. Well, we just learned that all I have to do to find this angle is take the two non-adjacent angles and add them up. So angle TYL is going to equal 57 plus 48. Once I add those two together, I find that TYL equals 105 degrees. And it really is just that simple. Let's look at another example. This time I'm finding angle RBF. So this angle right here. I have an exterior angle. I know that by the exterior angle theorem, I have to add up the two angles that do not touch the exterior angle I am finding. So angle RBF is going to equal whatever 24 plus 127 is, which it turns out to be 151 degrees. Now, this example is slightly different, but again, nothing we can't handle. This time I'm finding the measure of angle W, which is this angle right here. Now, I know that my exterior angle, 82 degrees, has to equal the two angles that it does not touch. So angle W plus 17, because my exterior angle equals these other two interior angles added together. And so now it's just like what we were doing before, but this time my variable is right here. So I have an extra step this time. The only difference that this is now I have to subtract 17 from both sides. I have to take an extra step just to get angle W by itself. So as soon as I do that, I find that the measure of angle W is 65 degrees. If I go back and check that, 65 plus 17 gets me back to 82. We'll see one more example of that. So this time they want to know the measure of angle TPL. So this angle down here. I know that the exterior angle, 160 degrees, is equal to the two interior angles that do not touch it. So 103 plus angle P, or TPL. And just like before, now I do have an extra step. I have to get angle P by itself. So I'm going to first subtract 103 from both sides. And we're going to find that the measure of angle P is 57 degrees. That's all for today. Pretty straightforward, somewhat short video. Thank you for watching. Please let me know if you have any questions, and I hope you have a wonderful rest of your day. Bye.